as we studied that power of a lens is inversely proportional to its focal length. That means shorter the focal length, greater is the degree of convergence or divergence for a given beam of ray, and longer the focal length, lesser is the degree of convergence or divergence for a given beam of ray. So we can say power of a lens is the reciprocal of its focal length. Thus we can write power is 1 upon focal length. Okay, so this is the formula we have obtained. And if I talk about SI unit of power, the SI unit of power is diopter or can be written as capital D, but only when the focal length is expressed in meter. So remember, this unit of power is diopter only when focal length is expressed in meter. So I can write power is expressed in diopter when focal length is expressed in meter. Very important. And if I have a lens, suppose whose focal length is 1 meter. I have got a lens whose focal length is 1 meter. Then its power is said to be 1 diopter. So how can I define 1 diopter? So the power of a lens is said to be 1 diopter if its focal length is 1 meter or unity. You can say power of a lens is said to be 1 diopter if its focal length is 1 meter. Very simple. One more thing I would like to tell you about the sign convention. This is very important. And we know that according to sign convention, for convex lens, focal length is positive. So focal length of a convex lens is always positive. So since focal length is positive, power will also be positive. And you must be aware that convex lens is also called as converging lens. That means a positive power indicates convergence. So for convex lens, F is positive, that indicates P is positive, that indicates convergence. That means positive power always indicates convergence. And for concave lens, F is negative. For concave lens, F is negative. Simply you can say power will also be negative, and concave lens is called as the diverging lens. So we can say negative power indicates, come on tell me, divergence. It indicates divergence. Okay. One more topic I would like to tell you, that sometimes instead of one lens, we have a system of 2 or more lenses kept together. Now suppose I have got 3 lenses over here of power P1, the power of the lenses are respectively P1, P2 and P3. Now instead of one lens I have 2 or more than 2 lenses, then the entire lens will act as a single lens of different power. So if there are 2 or more lenses, the power of the combination, or you can say the effective power of the system is P. This P is the total power of the 3 lenses, and it will be simply sum of the power of individual lenses. So if I have got 2 lenses of power P1 and P2, the effective power will be P1 plus P2. And if I have got 3 lenses of power P1, P2, P3 respectively, the effective power will be P1 plus P2 plus P3. But whenever you are using this formula, remember you have to use sign convention. What I mean to say that means if a lens is convex, the power will be positive, and if lens is concave, the power will be negative. And using this formula, I can also get the effective focal length of the lens. That means this P can be written as 1 upon F. So here this F is the effective focal length of the combination, and P1 can be written as 1 upon F1 plus 1 upon F2 plus 1 upon F3. Remember, whenever you are substituting the values of F1, F2 and F3, you have to use sign convention by checking the nature of lens, whether convex. If it is convex, then focal length will be positive, and if it is concave, the focal length will be negative. And what if this total power total power or total focal length comes out to be positive. So you have got two or more lenses acting together, right? If they are joined together, and if the total power comes to be positive, then that combination indicates convergence. That means this system will converge a given beam of ray if total power comes out to be positive, and if total power comes out to be negative, then this system will show divergence. That means a ray of light passing through this system appears to be diverged. Thank you.